So for our last example, we want to give an appropriate form for the particular solution to the differential equation y double prime minus 3y prime plus 2y is t to the fourth plus 7e to the 3t. Now remember, on all these equations you have to start by solving the corresponding homogeneous differential equation. So in this case, we solved the homogeneous equation back in example 1. You can check back there if you don't remember how we solved that, but it was using the characteristic equation. We figured out that the homogeneous solution was c1 e to the t plus c2 e to the 2t. So that was the homogeneous equation. And then the way you guess a solution to the inhomogeneous equation is you use functions that look like the right-hand side. Now in this case, we've got a kind of combination right-hand side. There's a t to the fourth term, and there's an e to the 3t term. We're going to treat those totally separately and solve for those completely separately. So we're going to guess for the first term there, we'll make our first particular solution. I see a t to the fourth, which means I need a fourth degree polynomial, generic. I can't just say at to the fourth. I've got to say at to the fourth plus bt cubed plus ct squared plus dt plus e. And we would take that guess and we would solve y double prime minus 3y prime plus 2y is equal to t to the fourth. We would solve that for the undetermined coefficients a, b, c, d, and e. So that would be the first part of solving this problem. By the way, we're not actually going to go through and solve for all the coefficients here. It would be really messy. The idea of this problem is just to figure out what the general form of the guess would be so we kind of understand the ideas without getting too bogged down into the nitty-gritty details. So after you solve that part, then you have to deal with this 7e to the 3t. So we'd guess a new particular solution, yp2. Now I'm going to guess something of the form e to the 3t, so I'm going to guess generically, well, I don't want to use a again because I already used a above, so I'll use f e to the 3t. And then you would find the first derivative, second derivative, plug it in, and solve y double prime minus 3y prime plus 2y equals 7e to the 3t. We would solve that for capital F. So that would give us a particular solution that matched up the e to the 3t part of the equation. And then once we'd found all those coefficients, a, b, c, d, e, and f, we would use our y particular. We would just add those two solutions. So yp1 plus yp2, or once we'd found those coefficients, at squared plus, at to the fourth plus bt cubed plus ct squared plus dt plus e plus f e to the 3t. That would be our final particular solution. And if you wanted to find the general solution, as usual, you would take the homogeneous solution and tack on the particular solution that you had found above by filling in all those constants. So the key idea of this example, just to recap here, is that when you have a combination right-hand side like this, what you want to do is split it up into the two different types of functions. So we have a polynomial part and an exponential part, and sort of solve for particular solutions separately. This is all, of course, after finding the homogeneous solution. So your first particular solution is to match the polynomial part. You guess a generic polynomial of the same degree. So the degree was t to the fourth, so you got to guess a generic fourth degree polynomial. Plug it in, find its first and second derivatives, solve for all those coefficients. It would be kind of messy, which is why I didn't want to work it out. And then you would find the exponential part by guessing a generic exponential term. It doesn't match anything in the homogeneous term, so we don't have to bump it up by t like we did in the previous example. You just find its first and second derivatives, plug it in, and solve for f. And then those two particular solutions that you found, one for the polynomial part, one for the exponential part, you'd add them together and get your combined your combined general solution there. Let me clean that up a little bit. And that would be, your combined particular solution. And then you would add that on to your homogeneous solution to get your general solution. So that's the end of our lecture on undetermined coefficients.